dear respected author and participant of IORA, the 5th International Conference on Operation Research 2020. I am Loridho Pratama. I want to share my research result. The title of my research is the disturbance characteristic of the uninterruptible power supply system in the frequency range 9 to 150 kHz with capacitive load level variation. The author of this research is Loridho Pratama, Budi Sudiarto, and Rudi Setiabudi. Our paper number ID is 34. Background of the research, as we know, the need of the electricity is increased year by year, and in the vital places like the hospital and other vital places is need the supply of electricity that cannot be interrupted. So we need the device that can back up temporarily when the main supply of the electricity is interrupted. So we can use the uninterruptible power supplies, or we known as the UPS, for the device that can back up the electrical system supply in a certain time. And the UPS is working when the supply system from the main electricity is interrupted. So when the UPS working, the UPS back up the electrical system with the voltage from the battery. DC voltage from the battery is being inverted by the inverter inside the UPS. As we know, inverter is the most important component inside the UPS, but the characteristic of the inverter is non-linear, so it can cause the distortion of the electrical system. And then it is necessary to standardize high frequency disturbances. The research methodology. This is the flowchart of our research. We start from the literature study. We collect the paper and read the paper that about the disturbance in the high frequency, and we prepare the tools and the material for this research, as the UPS itself, the oscilloscope portable or the portable oscilloscope, the PC, and I use the laptop in this research, and then the high pass filter. After that, when the tools and the material is ready, we start the research. We make the variation of the load level capacitance that connect to the UPS, and then we get the data. The oscilloscope, the portable oscilloscope that record the data, and then we see if the tools and the measurement tools is accurate, and if no, we need to calibrate the measurement tools. But if the measurement tools is ready and accurate, and then we make the data analysis, and then we finish, we make the conclusion of our research. This is our measurement system configuration. From the grid utility or the main electrical supply to the system, we connect our 1 kVA UPS, and then the output from the 1 kVA UPS we parallel between the variable capacitance load and the high pass filter. The high pass filter then connected to the portable oscilloscope, which the portable oscilloscope have the power from the USB connection from the PC or the laptop. And result and analysis. This is the measurement of disturbance toward capacitive load level. This is the first picture present the result of the disturbance voltage that generate at the load of 3.6 microfarad. As we see, this is between two pictures, and the second picture is the disturbance voltage at load level of 7.2 microfarad. There are three dominant frequency range that generate the highest or peak of voltage disturbance, which this is the 15 to 24 kilohertz, and then 35 to 44 kilohertz, and the third dominant frequency is 105 to 114 kilohertz. And this is the disturbance voltage at load of 14.4 microfarad, and the fourth picture is disturbance voltage that generate at load of 28.8 microfarad. As we see from the fourth picture, from the lowest load that connected to the UPS, the 3.6 microfarad, until the highest load that connected to the UPS, 28.8 microfarad, the disturbance voltage is increased by the increase of the load that connected to the UPS. We make it simplified to the table. We see from the table, the 3.6 microfarad is nearly 10% load that connected to the UPS, until the 28.8 microfarad is nearly 28% load that connected to the UPS. And from the graph, we see that the yellow line is represent the 3.6 microfarad, and the blue line is represent the 7.2 microfarad, and the green line is represent the 14.4 microfarad, and the purple line is represent the 28.8 microfarad. We can see from the graph that as the increase of the load level from the capacitance load, the disturbance is increased from the 3.6, 7.2, 14.4 until the 28.8. And this is the range frequency that generates the disturbance voltage at the UPS that we use in this research. And the conclusion, based on the result of measurement of disturbance voltage at the frequency 9 kHz to 150 kHz with capacitive load level variation in the UPS system, the following conclusions were obtained. UPS system has disturbance voltage peak which are dominated with three frequency range. There are 15 to 24 kHz, 35 to 44 kHz, and the third dominant frequency is 105 to 114 kHz. The second one is the disturbance voltage peak, which are generated in UPS system that are connected to the capacitive load level variation, has the highest voltage peak at 19.8 kHz and 19.6 kHz. And the last one is, as the capacitive load level increase, the disturbance voltage also increase. When the load level is 10%, or when the load connected is only 3.6 microfarad, the disturbance voltage is only 195.07 millivolt at the frequency of 19.8 kHz. And then when the load that connected to the UPS is 28.8 microfarad, or nearly 80% load that connected to the UPS system, the disturbance voltage increased until 309.53 millivolt at frequency of 19.8 kHz. And here is our reference for this research. There are 10 references. This is the end of our presentation. Thank you for your attention.